Okay guys, I know this isn't ideal, but we're going to give this a shot here. So what I'd like you to do today is just watch this video note about writing equations of lines and then try some in the practice packet. Mr. Wallach is going to be by probably about the second half of class, about 15 to 20 minutes left, and just make sure that you guys are good and that you have, if you have any questions, you can ask him. So again, just watch the note, take the notes just like you would if I was there, and then give some practice problems a try in the 2.3 practice packet, and then I'll check in with you on Tuesday, okay? So these are things that you probably learned last year, but I just want to go through and make sure that we're all good here. So the first thing that we're going to talk about is point-slope form. Point-slope form is probably the easiest way to write the equation of a line, or at least to start with. So point-slope form, if you remember, goes y minus y1, and that's equal to m times x minus x1. So what this means is that when you write the equation of a line, you're going to plug in two things. You're going to plug in a point where x1 and y1 go, and then you're going to plug in a slope, okay, and slope stands for m. The second equation that you'd use is slope-intercept form, and slope-intercept form goes y equals mx plus b. Okay, m still stands for slope, so m is the same thing that it was in your point-slope form, but then b is a little bit different. B is called your y-intercept. So this one, you really only use this equation when you are given the y-intercept. Most often than not, you're going to start every equation that you write for a line in point-slope form. We don't have to worry about standard form. We're going to do that later, if at all. So don't worry about that one today. Just focus on point-slope form and slope-intercept form. And like I said, you usually start in point-slope form and you work your way into slope-intercept form. The last two things we're going to talk about before I show you some examples are parallel lines and perpendicular lines. So two lines that are parallel are going to have equal slopes. Okay, so they're going to have the same slope. If line 1 has a slope of 1/2 and a line parallel to it will have a slope of 1/2. Okay. Now perpendicular lines are going to have opposite reciprocal. So op-recip. So I'm going to abbreviate this. Okay, opposite reciprocal slopes. So what this means is if you're opposite, and that means you have a different sign. So if it was positive, the opposite reciprocal would be negative, and vice versa. And then the reciprocal is just the flip of the fraction. So if line 1 has a slope of 2/3, a line parallel to that would have a slope of negative 3/2. Okay, just like if it was a whole number. Okay, if line 1 had a slope of negative 3, the line perpendicular to that would be 1/3. Okay, it'd be positive, and it'd be the flip of 3/1. Okay, so using those things, we're going to take a look at a couple examples down below. So in number 1, it says, given the line 3x minus y equals 1, write an equation of the line parallel and perpendicular that passes through the point -3, -5. So what's important here is that you know how to write, or what is important in writing the equation of a line. So when you're writing the equation of a line, you need to know two things. You need to know a point, and you need to know the slope. If you have those two things about the line, you can write the equation of it. In order for us to determine what the slope of this line is, we have to solve for y. So when we solve for y, we're going to get y by itself. Sorry about that. We've got 3x minus y equals 1. So we're going to get y by itself and subtract 3x. So if I subtract 3x from both sides, I get negative y equals negative 3x plus 1. And then we want to go ahead and divide by -1 here to get y completely by itself. So you got y equals a positive 3x minus 1. So what's important here is the number that's in front of the x. This is your slope. So 3 is our slope here. So I'm going to just go ahead and erase this. Keep this on your paper. I'm just running out of room. So our slope of the line that's given to us is 3. So m equals 3. And if I want to write a line that's parallel to this line, the new slope is also going to be 3. And the point is going to be -3, -5, because that's what it says in the problem. So I'm going to write it in point slope form. So remember, in point slope form, you have, okay, point slope is y minus y1 equals m times x minus x1. And you're only replacing 3 things. You're replacing the y1 with your y coordinate of the point, x1 with the x coordinate of your point, and then your slope, obviously, with your slope. So you're going to have y minus y1, which is -5, equals your slope times x minus the x coordinate of the point that this line goes through. So the only thing left to do here for point slope is to change the subtracting a negative into a positive. So y plus 5 equals 3 times x plus 3. And that is all you have to do if you want the equation of a line in point slope form. To get it into slope intercept form now, you're going to take your point slope form and you're basically going to simplify it. You're going to distribute the slope into the parentheses, so I'm just going to rewrite this. Y plus 5 equals 3 times x plus 3. I'm going to go ahead and distribute the slope here. So I got y plus 5 equals 3x plus 9. And then you're going to subtract the 5. So you're left with y equals 3x plus 4. And that's all you got to do. So what I'd like you to do is to go to this next one and see if you can try the perpendicular. Okay, remember, perpendiculars are opposite reciprocals. So go ahead and press pause and give it a shot yourself, and then press play. Okay, so since your slope was 3, your perpendicular slope is going to be -1/3. Your point is still the same. So your point slope form is going to be y plus 5 equals -1/3 x plus 3. And then your slope intercept is where you distribute your slope. So you got y plus 5 equals -1/3 x. This is going to be -1 now. Okay, 1/3 times 3, you just multiply the 1 times the 3. Okay, and then we're going to subtract the 5. So you got y equals -1/3 x minus 6. And that is slope intercept, and this is point slope. Okay, the last one I'm going to have you try is number 2. It says line E has a slope of 1/2. Line G contains the points 3a minus 2, 7, and a, 6. Find the value of a such that E and G are parallel. So think about what you know about parallel lines, okay, and what it's given to you here. The slopes of parallel lines are going to be the same. In math, the word same means equal. So if the slope of G has these 2 points, remember, in order to find slope, you take y2 minus y1 over x2 minus x1. So we're going to do that same thing here with the lines of G. So we're going to take y2, so we're going to say 6 minus 7 over a minus 3a minus 2. So I'm just going to go ahead and simplify this. It's going to be -1 over a minus 3a is -2a. And then when you distribute the negative here. So this is the slope of G. And this should equal the slope of line E, which is 1/2 because they're parallel. So I'm going to set that equal. And now what you got to do is just cross multiply in order to find out what a is. So 2 times negative 1 is negative 2. And then 1 times the denominator is just negative 2a plus 2. We're going to go ahead and just solve this equation. You're going to get negative 4 equals negative 2a. Divided by negative 2, you get a equals 2. So what I'd like you to do now is I'd like you to go and try in your practice packet. It's labeled 2.3 practice packet in Schoology, and I'd like you to try numbers 1 through 6.